These are the solutions to the 2017 quadratics analysis task. So let's get cracking. Alright, we've got a cricketer striking a cricket ball such that its height is h meters after it's travelled x meters horizontally. Okay, so the first thing they want us to do is sketch the graph. So let's mark our Cartesian plane. We've got x versus height. Okay, that's what this shows. Alright, so the best thing to do here is, because we're tech active, is to have a look at the graph on the calculator. So we're going to add a graph and type it in. 1 plus 3 over 5 multiplied by x, take away 1 on 50, multiplied by x squared, when x is greater than or equal to 0. Now, we're not going to worry about restricting the domain on the calculator. All we're going to do is make sure that we restrict it on the Cartesian plane when we sketch it. Alright, so there it is. Alright, so you've got to adjust your screen dimensions now. So we can see here that the max is probably within this range here. So what we're going to do is just extend our x-axis out. It's probably halfway. So that's probably the max there. So I'm expecting the other x-intercept to be somewhere like 20, 25, but just to be sure, let's go 35 and see if we pick it up. And we have. Alright, so let's get the key features. The way we do that is we're going to get the y-intercept. We don't need this x-intercept because it is for values of x less than 0. We're going to grab this x-intercept over here. So we're going to use menu and analyze graph. We'll get the 0 first of all. That's this one. Alright, so that 0 occurs at 31.6, 0. And the second thing we'll get is the turning point. That's a maximum, and that occurs at 15, 5.5. Alright, so let's mark in some of these points here, or all of these points. Let's grab the y-intercept as well, actually. So what we'll do is we'll go menu and trace and graph trace. Now what graph trace does is says basically, hey, I'm waiting for you, give me a value for x and I'll give you the relevant value for y. So if I type in 0 now, it comes up automatically with x equals 0, you can see on the screen there. So if I hit enter on my calculator now, it snaps to the y-intercept, which is 0, 1. Alright, but we might have been able to detect that even from here, that's the y-intercept. Okay, so let's mark it in. So we've got 1, we've got the x-intercept over here, which is 31.6, and we've got the turning point, so there's 25.5, so it's a little bit under halfway. 15, 1, 2, 3, 4, and 5, and 6. Alright, so there's our turning point there. Our y-intercept and our x-intercept. Alright, so we just got to make sure we pay attention to shape now. I'm using a stylus here, so it's a little bit difficult to get the shape right, but with a pen and paper, it's really important that our parabola looks symmetrical and it has a good clean turning point there, not too sharp as it attacks the turning point there. Okay? Alright, so here's my attempt at it. That's not too bad. Alright, now let's think about the domain and whether we include these endpoints. And of course, in this case, we certainly do include the endpoints. Okay, so we're going to do a solid circle and a solid circle because when the cricketer initially strikes the ball, it's there. Okay, at the y when x is 0, y is 1, and when the ball lands, it is at that point there. Okay, so let's start answering some of these questions. From what height above the ground was the ball struck? So this is when x equals 0, the initial value. Okay, and we can see there that's at 1 meter. Okay, and you don't need any working out for that. That's all you need. What's the maximum height reached by the ball, and how far horizontally has it travelled? Alright, so we need to first of all say max height, and the max height occurs here. That equals 5.5 meters, and how far horizontally? It's there. Okay, so horizontal distance equals 15 meters. Okay, so again, don't need any working out on that. That's that we got your full 2 marks. If a fielder caught the ball when it was 2 meters above the ground, how far could the ball be from where it was hit to 2 decimal places? And why are you going to get 2 answers? Right, so there's a couple of ways of doing this. What you could do is in graph, you put in you add another function. So I hit tab and I'm going to put in y equals, or f of x equals 2, and hit enter. And then what we're going to get off the graph is the 2 intersection points. Okay, so let's go menu, analyze graph for the intersection, and there's the first one. And let's do the same, menu, analyze graph, and intersection, and there's the second one. Alright, now let's be careful here. Alright, so this is a bit of a flaw with the TI Inspire. It wants it to 2 decimal places, and you note there that that one is the 2 decimal places. This one here has 1 decimal place on it, and it has to do with how many decimal places the calculator is going to show us. So let's click on the point there, or just select it. Okay, and what we're going to do is once we've selected it, okay, we hit, I've forgotten the menu option again. Menu, actions, was it? Yeah, menu, actions, and attributes. Okay. And what that does is allow us to change the precision. So at the moment it's 3, we're going to bump that up and to 5, just to make sure that it is 1.77 to 2 decimal places. Let's do the same thing for this one. So attributes, and bump it up to 5 as well. Alright, so we've got 28.23 and we've got 1.77. So our answer to this was, so if a fielder caught the ball when it was 2 meters above the ground, how far could the ball be from where it was hit? So it's these x values here. So it could have been 1.77 meters, or it could be 28.23 meters. Now, why 2 answers? Well, it's easy if you think about it. Okay, if this is the cricket ball being struck and being caught, the ball might have been hit and the person who was fielding caught the ball on the way up. Or imagine the cricketer smashed the ball, it goes high in the air and then comes back down, and then the fielder catches it there. Okay, so an answer something like fielder could either catch ball on, and I'm just sort of using a bit of shorthand here, on the way up or the way down. Okay. Alright, so there's question 1. Alright, generally done well in this task, so that was a pretty good effort. Okay, question 2 is the classic sort of building problem, and yeah, again, these ones always come up. Okay, so what we've got is a builder has 90 meters of timber to make a frame. Shape and dimensions in meters of the frame are shown below. Alright, so how to attack these ones? I know I'm going to use perimeter and area, so what I do is I generally, before I really look at the questions, I'll fill in all the side lengths. Okay, now this side length here is x plus 2x. This side length here is 3x. Y, 2y gives us this side length here, so that's 3y. Alright, so the first thing they want us to do is to show that y equals 5 take away keep color. Alright, so yeah, we're going to say that we know that the builder has 90 meters of timber to make the frame, and we want to show that y equals 15 take away x. Okay, so essentially what we're going to do is use the perimeter formula. So we're going to say 90 equals, alright, let's add together the sides. We've got 3x plus 3y plus 2x plus 2y plus x plus y. Alright, collect up your like terms. 90 equals 5x, 6x, and 3y, 2y plus 6y. Alright, we're going to make y the subject, so let's go 6y equals 90, take 6x, divide by 6, divide all of this by 6, y equals, 6 goes into 90 15 times, that cancels out, that's 1, so we're just left with y equals 15 take away x. Alright, so we've shown that. Alright, now we're going to show the area in meters is given by this formula here. Alright, so what we'll do is we'll use some composite areas. Alright, so let's go, this is shape 1 and this is shape 2. The area of this shape here will be xy, and the area of this shape here will be 6xy. 2x times 3y is 6xy. And what we're going to do is go xy plus 6xy equals the area. Okay, so that's our formula down here. Area equals xy plus 6xy. But that's not that. Well, what can we do about that? Yeah, well, there's no y's in that. And so what we can do is actually use this definition of y. We know that y is equal to 15 take away x. So if we sub 15 take away x into this, what we should get is 105x take away 7x squared. Let's try it. X 15 take x plus 6x 15 take away x. So we've got 15x take away x squared plus 6 15s, 60, 90, x take away 6x squared. Alright, so let's collect up our like terms. Area equals, now we've got 15x plus 90x equals 105x. Ooh, this is looking good. Negative x squared, subtract another 6x squared is negative 7x squared. Done. Alright, state the possible values that x can take for the area to exist. This is really, really difficult to answer without actually looking at the graph. Okay, so my next move, absolutely without doubt, is to go to my calc now and have a look at what this graph looks like. So we're going to go new document and go add graphs. Alright, so we're going to go 105x take away 7x squared and graph. Alright, so you get this, and what that usually says to me is when it looks linear or goes virtually straight up, this the range or the maximum of this function, because what we're going to get is an inverted parabola here, is going to be really, really high. Okay, so like 6 doesn't even do it justice. So yeah, that's certainly one thing. So let's, I don't know, 500. Oh, lucky guess. Alright, so there's a little bit of guesswork involved. You can actually do some algebra in calculator and find out what the turning point is by running complete the squares. There's a few moves to make, but a good educated guess will sort of get you there fairly quickly. You can also use the zoom options to have a look. Now, what I'm going to do is move this across. I'm just using drag by using this thing here and clicking there to drag it. And let's just move it to, say, 20 and just see. Alright, so now I've got my whole parabola in. Alright, so now these are the value for x versus area. That's what I've plotted there, x versus a. Okay, so what we're getting is values for x, and remember x is a side length. Alright, so it's actually all of these values of x in quadrant 1, okay, all of these values for x will produce an area. except at the origin, because x will be 0, and at this x-intercept here, alright? Because what that will mean is that x is 0 at that point, and you can't have a side length of 0, okay? Or if you do, have a look. If x is 0, 0 multiplied by that produces no area, okay? So it doesn't make sense. So let's find out and double check what these values are. So I'm going to go menu, let's analyze the graph for its zeros. Let's do the lower bound. Yep, it's definitely at the origin. Should be obvious. You know, because there's no plus, no constant in that, so it should be obvious that it goes through the origin, but doesn't hurt to confirm. Analyze graph for zeros, and let's do the second 0 at 15, 0. So this x can be between 0 less than x less than 15. So it's really important that it goes to 15, but it doesn't include either 15 or 0, because they will produce 0 area, okay? And what we're after is the area to exist. So let's sketch it now knowing these things. Alright, so we've got 15 here, 0 here. Now we're going to have open circles here at these endpoints. We don't include them, so it's really important that our graph reflects that. And let's go to the graph, analyze it for its max, which occurs there at 7.5 and 394. Now there's no indication on the rounding they're expecting, so we can just put that in verbatim. So it's 7.5 and 394. Alright, so again, excuse my parabola if it doesn't look very parabolic. It's hard to do these with a stylus, but let's give it a go. Ooh, that's hideous. Alright, so yours really need to be straight lines there. With a pen and paper, if you know, I'd make sure I get that right, okay? Because these 3 marks here, what we were looking for was, I think it was 1 for the TP, the turning point, 1 mark for ints, and 1 mark for shape. So if yours didn't look parabolic, we knocked you down for 1 mark. Alright, hence find the maximum area in meters squared of the frame. Now, this is important. We need to label our axes, so that was a bit naughty of me for not doing that. And remember, what this means is this is the area. This is when the area is at its maximum. So the maximum area is 394 meters squared. Right, heaps of people got this one wrong. Values of x and y for which this occurs. So what a lot of you did was you said that it occurs at 7.5, 394, when x is 7.5, y is 394. That's not true. Alright, the x value is definitely 7.5, okay, but that's not the y value. Remember, the x value of 7.5 according to this gives you the area, okay, the maximum area. So what you needed to do is go back, alright, to your definition of what y is. Y equals 15 take away x. And if y equals 15 take away x, if x is 7.5 and y equals 15 take away x, then y equals 15 take away 7.5, y equals 7.5. Okay, so they were your 2 values there. Okay, so I probably only saw 1 or 2 students in my class actually say that that was x equals and y equals. A lot of you guys just wrote 394. Okay, so think about what the graph is showing you before you commit to an answer for these ones here, and read what variables we're actually trying to get you to state the value of. Okay, so it's a pretty tough question, this question 3 here. Alright, so we've got students working on constructing a set for a player required to build an archway. It's to be in the shape of a parabola. Stage is represented by the x-axis, so we've got the stage here. The y-axis represents the height above the stage. Okay, so there's the y-axis is height, and the stage is the x-axis. Okay, so this is the stage. Alright, so the first thing is that this curve has an equation of y equals negative x squared plus 6x plus 16. They're giving it to you, but they're saying show it. Alright, now what a lot of you did was chose one point, subbed it in, and said, yeah, that's the equation. But that's not good enough for a show that. Some of you factorized this, then said that they were the two x-intercepts. Again, that's not showing the equation, okay? So what we need to do here, girls, is work off the general form. So we're going to say that y equals a, and the general form, I don't know what exactly it is, but x takes c. Looks something like that, okay? When we're in intercept form, we've got a dilation, okay? And we've got an x-intercept there and an x-intercept there. Alright, now what we're going to do is fill this in, okay? So y equals a, x plus 2, x take away 8. They're the two intercepts that we're given. We know this, okay? So we can fill these in. What we don't know is whether this parabola has been, or the dilation factor, although we do know that it has been inverted. So I know that a is going to be negative, but we'll worry about that. That'll take care of itself later. Alright, so what I need to do is to find a, I need to sub in a value, and it can be any value that I'm given. I could do negative 2, 0, 0, 16, or 8, 0. I'm just going to do this one here. It's just the easiest value, okay? So when x is 0, y is going to be 16. So let's let y equals 16 equals a 2 negative 8, because x is 0 and y is 0. 16 equals 2 times negative 8 is negative 16a. A equals negative 1. Alright? So now I can state the formula. The formula is y equals negative 1 x plus 2 x take 8. Alright. Now what we're going to do is the finishing touch is we're going to show how that and that are the same thing. Y equals negative x squared plus 2x take 8x is negative 6x take 16. All of these values are negated, so it's y equals negative x squared plus 6x plus 16. That's convenient. That's what that is. Alright, the arch must fit below a horizontal lighting beam which is 30 meters above the stage. Okay, so find the height of the arch. Well, that's easy. That's its max. Okay, so what we're going to do is again go to our calculator and plot it. So new document and graphs, and let's type it in. Negative x squared plus 6x plus 16. And screen dimensions are easy this time because 16 is the y-intercept. Let's double it and go 32. And let's find out the max. Menu, analyze graph for its maximum, 325. Okay, so the arch must fit below a lighting beam which is 30 meters above the stage. Find the height of the arch. Okay, so that's what it goes up to. So it's 25 meters, and it does certainly fit under the beam if the lighting beam is 30 meters above the stage. Okay, so that's going to be 30 take away 25 equals 5 meters. So it is 5 meters clear of the stage. Alright, the lighting beam falls and lands against the arch at a point 5, 21 and hits the ground at 41 on 4, 0. That's the lighting beam. Alright, so the first thing is they want us to find the equation of the fallen lighting beam. Alright, the lighting beam's a straight line, it's linear. So to find the equation, first of all I need to grab the gradient and then I'm going to use that formula to find the actual equation. Alright, so m equals y2 take y1 over x2 minus x1. I'll show you a neat way to do this as well in a sec. M equals, so we've got 21 take away 0, 21 over, we've got 5 take away 41 on 4. Excuse the handwriting. 41 on 4. m equals. Alright, now just need a common denominator for the denominator. So we got 21 over, we've got 20 on 4, take away 41 on 4, m equals 21 over negative 21 on 4. That's the same as m equals 21 divided by negative 21 on 4. M equals 21 times 4 over 21, negative 4, they cancel out. M equals negative 4. Some nasty fractions there. Now, another way you can get the equation, this is something we haven't shown you, but it's pretty cool, so I'll give you a look. We're going to hit Control Doc, and for the first time this year in methods, we're going to go into, not data and statistics, we're going to go into list and spreadsheet. Alright, so what you do in list and spreadsheet is you type in, well, you give your columns a heading, X variable and Y variable or Y value. So 5, 21, and you type in your 2 points like so, 41 over 4 and 0. And what we're going to do is we're going to run what we call linear regression on this. Now I haven't got time to explain really how it works. So we're going to go menu 4, 1, 3 to do linear regression. X list is the X value, Y list is the Y value or variable, and we hit OK. Now what it does, it performs a statistical analysis on it and gives you a line of best fit for the 2 points. And it just so happens that the line of best fit has a gradient of negative 4. Well, that's what we just found out here. It also tells us that the b value or the constant is 41. Alright, so I know my equation is going to be y equals negative 4x plus 41, but we're going to go through again the old-fashioned way and just finish it off by hand. But you'd be very comfortable running regression on this and actually just writing the formula out. It's only 1 mark, so we're just looking for a right or wrong answer. So at this stage I know that my formula will be, so we're going to use y plus y1 equals mx, y take y1, I've forgotten the formula. Y take y1 equals mx take x1. Y take away, and we're going to use this coordinate point here, y take away 21 equals negative 4 x take 5. Y take away 21 equals negative 4x plus 20. Y equals, we're going to add 21 to both sides, negative 4x plus 41. That's our formula. Alright, so yeah, again, you could have done that by hand. You could have used the calculator to do y2 minus y1 for you. Didn't need to show working out for that. All we were looking for to allocate 1 mark is the answer. Alright, show that the beam is a tangent to the arch. Now what a lot of you did was solve this simultaneously. So what you did is you used this formula that you found and you solved it, and then the solution you got was 5,21. It wasn't quite what we were looking for full marks in this one. So show that the beam is a tangent to the arch. Well, let's consider our 2 equations. We've got y equals negative 4x plus 41 and y equals, I just need to drop back to the other page there, it was negative x squared plus 6x plus 16. Let me just check that, negative x squared plus 6x plus 16. Yep, alright. So the beam is when something is a tangent to a curve, what it does is that it's going to, we remember from quadratics, this is going to have a discriminant of 0. Okay, so if we actually equate the 2 equations and run the discriminant check on the result, what should happen is the discriminant should be 0. Right? So let's do it. Alright, so I'm going to let it equal 0. So negative x squared plus 10x. 16 take away 41. this is testing me out. 10, 4, 25. Take away 25 equals 0. Alright, so what we're going to do is run the discriminant on this. Okay, so you'll remember that the discriminant is b squared minus 4ac. Alright, and what should happen is the discriminant should come out as 0 if it is a tangent. So we've got b squared, which is 100, take away 4 times -1 times -25. Discriminant equals 100, take away 100, so the discriminant is 0. Therefore, tangent. Tough question, that one. Alright, the lighting beam is cleared and a second arch is to be built as shown below. The two arches have the same axis of symmetry and intersect 16 meters above the stage. Alright, so what we know is this line here equals, or is the line y equals 16. So what we're going to do is go back to our curve here and we're going to run, so I'm going to hit tab and type in an equation, y equals 16. What happened to it? There it is. Not sure what happened to that other one. And what we're going to do is find out what this point is. So we know that this point here is 0, 16. Alright, but we don't know what this one is. Alright. So let's get it. Well, actually I could guess. Alright, well, let's check this out. Right, so let's just do this. So what I'm going to do is menu and analyze graph for its intersections. Let's check what this intersection is. It's 6, 16. So find the values of x and y, 6, 16. Alright, and that's all you needed for the full 2 marks there. Alright, so now what we're going to do is find the equation of the second arch, given that it is of the form y equals x take h squared plus k. So a bit of a tricky one here. Okay. Now what you need to be aware of is you need to know a couple of things. If this coordinate point here, this is 0, 16. Alright. And let's go back to the original over here. Okay, we know that the maximum here, or this point here, was 3 and 25. Okay, so I do know something about the turning point of the other one, or the other parabola. So this parabola here, I know, will have an axis of symmetry of x equals 3. Right, but what I don't know is how far it's been elevated, the plus k. Alright, but let's fill in what we know. Alright, so I know it will be y equals x take 3 squared plus k. Right, so I know that it shifts 3 units to the right. Okay. Now what we need to know is k, right? And so that means we need to get a value for y and x that is on this parabola. Well, again, it's pretty easy. We've got 2 different options. We can use 0, 16 or 6, 16. I'm going to go with the easy one, 0. So we're going to say that y equals 16 negative 3 squared, because x is 0 at that point, plus k. That means that k equals 16 take away 9, k equals 16 take away 9 is 7. So our equation is y equals x take 3 squared plus 7. Alright, if the second arch is raised 1 meter, what's the new equation of this arch? Well, originally it was that equation. We need to send it up 1 more unit, which means that's plus 8. So our new equation will be y equals x take 3 squared plus 8. That addition of 1 there will just vertically translate it 1 unit up. And that's the end of the paper.